part. The fight is over what kind of thing carrying capacity is. Here's a fractal tree you can actually use to walk someone down. Starting at ontology, does the concept exist? Before you ever touch epistemology, can we measure it? Root, carrying capacity, ecological context. Definition in plain terms, a limit on sustained population or biomass, given constraints of resources, waste, and system dynamics. Inning 1, do you concede the concept exists? Branch A, yes, carrying capacity is a real feature of ecosystems. Their core claim, finite inputs, finite absorption equals eventual limits. What they're really conceding, ecology has constraints that can bind growth. Branch B, no, carrying capacity is not a real thing or is too sloppy to be real. Sub-branch B1, conceptual skeptic, claim nature doesn't have a single capacity, only shifting conditions. Carrying capacity is a story we tell after the fact. Sub-branch B2, boundary skeptic, claim capacity of what system? Boundaries are arbitrary, region, watershed, planet. If the system boundary is a choice, the capacity is a choice. Sub-branch B3, scale skeptic, claim what's true at one scale breaks at another, local versus global. Sub-branch B4, human exception skeptic, claim humans change constraints, technology, trade, substitution, so capacity isn't an ecological constant. What would make them soften, not fully convert, reframing carrying capacity as an operational concept, not an eternal one? Inning 2, only if they concede the concept. Can it be calculated? Branch A1, yes, it can be calculated. Branch A2, no, it cannot be calculated, even if the concept is real. Now it gets fractal. Both sides split again based on what calculate means. Branch A1, yes, it can be calculated, but what do they mean by calculated? Subbranch A1A, hard number realist, claim there exists a determinate K, a single value for a defined system and species. They want one number, like this island supports 12,400 deer. Subbranch A1B, probabilistic realist, claim you can calculate carrying capacity as a distribution, range with confidence. They want most likely range given climate variability, predation, disease, etc. Subbranch A1C, operational pragmatist, claim you can calculate a policy capacity, a level that is sustainable enough under chosen criteria. They want a threshold that keeps collapse risk below X%. If you ask how would we go about it, their answers map cleanly. A1 method family 1, limiting factor accounting, resource waste constraints. Identify limiting constraint, calories, water, nitrogen, habitat, nesting sites, thermal refuge, disease load, etc. Compute sustainable supply rate, inputs, and absorption rate, waste damage. Translate into supported population using per capita requirements. Output, usually a range, because requirements and supply fluctuate. A1 method family 2, population dynamics inference, data-driven K. Use time series of population plus vital rates, birth, death, migration. Fit models, logistic style, or more realistic structured models. Infer K-like behavior from density dependence. Output, realize carrying capacity under observed conditions, not a timeless constant. A1 method family 3, trophic energy budgeting, ecosystem energetics. Estimate net primary productivity and energy transfer up the food web. Allocate energy to target species based on diet and trophic efficiency. Output, biomass ceilings that can be translated into population counts. A1 method family 4, spatial habitat capacity, space as the constraint, habitat suitability plus territory home range requirements. Patch connectivity and edge effects matter a lot here. Output, capacity as a function of landscape configuration. Notice what all yes camps must do. They have to pin down scope, target species, time horizon, and what sustainable means, which opens the door to the no camp. Branch A2, no, it cannot be calculated, but why not? This branch splits into in principle versus in practice. Subbranch A2A, in principle skeptic, claim ecosystems are open, adaptive, historically contingent, no stable quantity exists to compute. Even with infinite data, the target isn't well defined because the system co-evolves with the population. Deep point, carrying capacity isn't a property like mass, it's a moving relation. Subbranch A2B, in practice skeptic, claim it's real but unmeasurable to precision because the needed variables are too many, too noisy, too interactive. Their emphasis, uncertainty is not a bug, it's the normal condition. Subbranch A2C, normative skeptic, often hidden, claim capacity smuggles values. What level of biodiversity loss is acceptable? What counts as degradation? So the number is partly a moral political choice dressed as ecology. When you ask them, what would we need to know for calculation to be possible, you can make their demands explicit. Information demands of the skeptic: what would need to exist? Complete system boundaries: what's inside outside, import export flows. Full accounting of limiting resources and their variability distributions over time. Per capita requirements as functions of density, age structure, behavior, and season. Feedback functions: how the population alters habitat, disease dynamics, prey availability, etc. Multi-species interactions: predators, competitors, mutualists, and how they shift with climate. Shock regime: drought cycles, fires, invasive species, extreme events. Clear sustainability criteria: what ecological state you're trying to preserve. For humans, technological and trade elasticity: how fast constraints can be shifted, at what ecological cost. That list is the philosophical punchline. The skeptic isn't always denying reality, they're denying tractability and stability. A useful reconciliation node where the tree can converge. If you want a number without cheating, the most defensible position is: carrying capacity is not a single constant. It is a conditional quantity. K, system, species, time horizon, climate regime, management rules, acceptable risk. What we can calculate is a range or risk threshold, not an eternal ceiling. So yes, you can calculate a number, but only after you declare what kind of number you're calculating: hard constant, probabilistic range, or operational threshold. Most disagreements disappear once people admit they've been arguing about different kinds of objects under the same word.